Good noon to everyone. Today discuss about in the mass transfer operation 1 liquid extraction continuous contact countercurrent extraction with reflux basis પર જોઈશું આપણે. Now the applications બી જોવાના છે સાથે સાથે. Now where is ordinary countercurrent operation the richest possible extract period and some product leaving the plant is at best only in equilibrium with the feed solution. The use of reflux at the extract end of the plant can provide a product even richer, as in the case of the rectifying section of a distillation column. Now, the reflux is not needed to the raffinate end of the cascade scenes, unlike a distillation where head must be carried out in the reboiler system by a vapor refluxes. In extraction, the solvent, the analog of a head basis, can enter without a carrier stream. An arrangement for this is shown in figure 10.27. The feed to be separated into its component, it's introduced at an appropriate place into the cascade through which is extract and definite phase. Liquid are passing countercurrently. The concentration of solute C is increased in the extract enriching section by the countercurrent contact with a raffinate and a liquid phases. This is provided by this removing અને સોલ્વન્ટના બેઝિસ પર જોઈશું આપણે E1 produce the raffinate phase and a stream E dash the part of the which removed the extract produce P dash E and a part of the return as a reflux R0 and the raffinate stripping section of the cascade in the same the countercurrent extractor in a figure 10.18 and C is stripped from the raffinate by the countercurrent contact with the solvent. Now graphically determinations of the stage wise required for such operations is usually inconvenient to carry out in a triangular coordinates because of the crowding and only the use of an xy coordinate system will be the described for the stage wise contact in the raffinate sieving section 10.31 10.34 ઇક્વેશન્સના બેઝિસ પરથી જોઈશું એને એપ્લાય કરવાનું છે આપણે જે આપણે પ્રીવિયસ લેક્ચરમાં ઓલરેડી જોઈ ગયા છે. This is a section of the plant need no further consideration. In the extract enriching section and A plus C a balance about the solvent and the separator is E1 dash is equal to E dash is equal to P dash plus R0 dash. Now this section of this section so in a flow diagram in this figure. Now this section of this part all the raffinate and extract phase में જોવાનું રહેશે આપણે. Solvent for first of all the flow diagram in this figure. Do in this diagram. Now this one. Okay, now this is the raffinate section and extract phase. Now બંને પર જોવાનું છે inlet and outlet section. So what is the main equations? This one E1 dash is equal to E dash is equal to P E dash plus R O dash. Let the delta E represent the net rate of flow outward from this section, and then for its 1 a plus c content, del E is equal to Pe dash E, and for its c content, x del E is equal to xpe, while for its b content, b is equal to del E dash એ આપણે છે સોલ્વન્ટ ફ્રી અમાઉન્ટ આપેલો છે આપણને, and del E. The point del E is plotted on this figure, which is drawn for a system of two partially miscible component pairs માં છે for all stages through a E and a plus c balance માટે E dash E plus 1 is equal to P dash E plus R dash E is equal to del E plus R dash E. Del E dash E is equal to E dash E plus 1 minus R dash E. Equations not done करो पहले तो first of all. First of all, write down this equation. All three for A plus C content માટે આપેલું છે, C content માટે, B માટે, પછી del E plotted માટે જે ફિગર 10.28 જોઈએ આપણે A plus C ના બેઝિસ પર, જે E plus 1 વાળી ઇક્વેશન્સ છે તે ઇમ્પોર્ટન્સ છે. A અને C બેલેન્સ માટે જોઈએ તો del dash E, E del x del E is equal to આના માટે છે, and B balance is this term in this formation. Now since is any stages section line radiating from this point del E, cut the solubility curve on a 10.28 figure at a point representing the extract and the raffinate following માટે between the any two adjacent stages. Del E is therefore a different point constant for all stages in this section whose coordinate mean del dash E માટેના બે ઇક્વેશન્સ છે, n del E અને x del E. તો આ બે ઇક્વેશન્સ લખી લો. this one એના માટે 2 પોઈન્ટ્સ છે, this one ના આઉટપુટ કયા છે આયરા ફ્લો B માટે અને C ફ્લો માટે. Okay, write down this equation now. Then after we complete the explanation part. Now this according to tie lines and the tie lines del E, then establish the stages starting with the stage 1, continuing the feed stage figure 10.28. Also show the raffinate stripping section part, developing the before for countercurrent extraction, solving equation 10.43, 45, 46. તો કઈ ઇક્વેશન આવશે? these two equations. Okay, now the R dash E by E dash E plus 1 is n del E minus n E plus 1 by n del E minus n R E is equal to x del E minus y E plus 1 by x del E minus x R is equal to line del E E plus 1 by line del E R E. This can be computed from the length on the upper diagram of the 10.28 or from the slope of this chord on the lower diagram as shown is the external refluxes is R dash 0 by R dash P dash E is equal to R0 by P dash E is equal to n del E minus n E1 by n E1, which can be used to locate del E for any specified refluxes ratio. This graphical system. First of all, they write down this equation material balance matter. પછી આપણે મેઇન ડિસ્કશન કરીશું આપણે. Now material balance also be over the entire plant for A plus C, F dash plus S dash is equal to P dash E plus R dash NP. For equation 30 to 40, now the F dash is equal to del R plus del dash E. Where normally F is equal to F dash, point F must be therefore lie on the line joint the two phases to different point and the optimum locations કયા કયા છે અલગ અલગ આપેલા છે. On the feed stages is represented by the line cross line અલગ અલગ. All the discussion part is with a figure wise આપેલું છે તમને. Now the second part for main equations and the example part. The higher the location del E and del R lower માટે and the larger the reflux ratio the smaller than the number of stages. When R 0 by P dash E is infinite, and infinite reflux ratio is total refluxes, and del E is equal to infinity basis for, and the minimum number of the stage wise result is, and the capacity of the plant falls to 0 and feed must be stopped the solvent basis, and the solvent BE is recirculated to become S, and the configurations is shown is figure 10.29 and the NXY some coordinate system. In the corresponding XY diagram used 45 degree diagonal basis per se as the operating line for both section of the cascade. An infinity of stage is required in this line. Okay, for S n plus 1 and finally is a downward ratio. ઇકોનોમિક બેલેન્સ જેમાં પોઈન્ટ નથી. ઓકે, સમ હવે લાસ્ટ વન આપણે એપ્લિકેશન જ જોવાની છે. Then chapter is completely over. Now the find out the applications, then I completely your chapter. Mass transfer including droplets stage efficiency. Now this is an important chapter, most probably 7 to 14 marks in this chapter. Overall the most of some example in 14 marks. ડિફરન્શિયલ એક્સટ્રેક્ટર જે પૂછાતો નથી એક્ઝામમાં. સ્પ્રે ટાવર, પેક ટાવર ઓલરેડી જોઈ ગયા છે આપણે. મિકેનિકલ એજિટેટેડ વેસલ, સમ એક્સટ્રેક્ટર છે, સેન્ટ્રીફ્યુગલ એક્સટ્રેક્ટર છે, સમ ડિઝાઇન, dilute solution. This is a some performance. Okay, the chapter is completely over. The next chapter જોવાનું છે leaching. Okay. ઓકે, this is the humidification operation આપણે જોઈશું ગ્રાફિકલી સિસ્ટમ વાઇઝ નેક્સ્ટ લેક્ચર. Thank you so much.